skyscrapers are built. Yeah, but the land is expensive in cities, so instead of building out, they build up.
I'm learning. Okay.
All right. Let's just keep rolling on. Take out that work from Monday and yesterday. If you saw yesterday's class online, we basically just kind of recapped everything, but we did finish number 2. So you're going to want, if you don't have this part down for number 2, like there's number 1 and number 2, you want to get caught up there. We're just going to roll on, see if we can knock out at least like 3 and 4 today. You can do those 2. But the process is just going to repeat. You get it now. We know what to do. So X and Y, no matter what we're doing. I'm going to use the calculator. I'm going to go back and set that up as often as I can. And just kind of go from there. So let's see how it works out. So if you need to get caught up, go for it. If you need copies.
Do you have any paper? Do you have a pencil or something?
You need paper now.
Yeah.
First you did her parking spot.
Yeah, I know. Steals my parking spot.
On her birthday.
Sorry. Yes, I could.
You don't need copies of paper. Where's that handout, John? John, there's this from 2 days ago. That's where it all happens. Where's this?
Guys, we were
2 days ago.
Okay, Rosengren. So tomorrow I'm flying to Texas, and I'm pretty sure I'll be here for this class.
We're just gonna keep rolling. Just keep rolling through.
The same thing.
We're gonna do all this until we're done. Yeah.
Okay.
Do you have 3 and 4? That I can have because I left mine at home on accident.
All together, all at once. That's why I make like 15 extra copies.
Same here.
That's
my lunch or something.
You know, I don't want to take this personally, but I kind of do.
It's hard, you know.
I kind of do take this personally.
Online and school because then I leave all my notes out on my desk and like something.
Yeah, no, that makes sense.
We're fully online and see anything.
All right, let's do it. I'm gonna erase number 1, so if you have to catch up on number 2, you have a minute to do that. So I'm gonna actually slide this over to you.
Do you think my captures out of lunch yet?
Yeah.
Bye. I love you. Happy birthday. Thank you.
Bye, Amber.
Bye, Rosie.
All right, cool. So, number 3, I just want to just keep going. We're just going to keep practicing. You're going to see that, like, by the end of this, you're like, man, it's the same thing over and over again. I feel really good about this process and how to do that. I'm going to lose the camera for a second because, yeah, I want to show you, again, just a reminder of how to find that table. Come over here, plug it in.
Did you ever figure out if there was like an online version?
So on the left there on the board, calculator X. That was the one that Stone found yesterday, and I haven't checked it out yet. That's what I want to do before I actually say, hey, this looks like a good one to download. But he found that and said it looks pretty good. You want one that just looks like this, all right? Let me share my screen with you guys at home. You just want to have like the actual calculator. Can somebody read number 3 to me? What's the function?
X plus 4. Okay, it has a 3. I don't know how to say it.
X plus 4. Okay.
Minus 7.
And so if that's that, and we're trying to find a way, and we're just going to do graphing part first, it's usually the easiest way to do it, right? We want it to fit in this space. It's okay. We want it to fit here, right? This is the kind of space that I'm looking at, and so if I want to create a table first, we're just going to start with that. Take a nice collection of points, bottom. If X is going to start over here at -10, then that's how I'm going to start my calculator. If it only went from like -5 to 5 or -50 to 6, whatever it is, whatever that space is, let's set up. So up here, I'm going to use the arrows to get the table. Right, that table set, the second window. I want to start at -3. Let's start it at -. And so if you do that PBL set, the second window to get you up there, you can make your table look however you want. Like going up by 1 is cool. You can go up by 5. You can make it go up by one half. Like you can do whatever you want. But if it's set to auto, that means it's automatically going to put in the X's for you and automatically spit out the ones over. You'll see, I don't know if we'll get there this year, but at some point I might show you why it's useful to change that.
Why did you put a negative 10 instead of 10?
Because I want my table to start at the first X value on the left.
Oh.
Because when I read graphs, I read them from left to right. And so when I read tables, I want to read them kind of the same way.
Oh.
Because now when I actually click on table, the second graph,
Oh,
it goes up. Like the numbers go up, right? So it gets towards positives and go from there. But again, if my X's go from -10 to 10, I'm going to have us do the Y the same way. Can we plot that first one?
No.
The second one?
No.
The third? No.
No.
What's a good one to start at?
-5, -8.
-5, right? Now I'm going to scroll just in case there's some other ones, but I don't think so. Like it's already at 20,
Yeah.
57. These numbers are only going to get bigger. So really? Only a handful of points, not even. Only 4 points that actually fit. Starting at that -5, the -4, -3, -2. That's it. Now, let's make that table. So I'm going to leave that up there just for a second so you can write that down. I'm going to come up to the front. I'm going to do the same thing. I'm going to give myself a table of X and Y. Now, if they called it f of X, I would have called it f of X. But I think it's just Y equals, right?
Yeah.
-5, -4, -3, -2. Those are the only ones. Numbers that go with them, -8, -7, -6, and then 1. Now, we haven't spent a ton of time messing around with cubic functions. I'm going to disconnect here for a second. We have not really messed around a ton with what these look like, but I don't have to worry about that just yet. Let's do the other one. Yeah, I like that idea. I think it's a really good idea right away, is as soon as you get your table for your function, let's there we go. Let's get a table for the inverse. So right next to it, a little xy. But there's something missing. All right, what are we missing that shows that this is actually the inverse? Yeah.
The -1 over y.
Nice, good, right? That little -1 on top of the y, because that means inverse. And so how do we make this table? Good. So flop. All your x's are now your y's. All your y's are now your x's. And that's what makes inverses just so nice and easy. If I can let the calculator do the work, you get it there. And the rest of it is pretty easy, right? Flip flop. And now let's make some. Take out a second color if you've got one, or do like we did last time. You can take one from me. Take a pen or a marker or something, but if you're going to take a pencil, just make sure it's sharpened enough. And I'll give you a ruler for a straight edge as well, so we can draw that line. Oh, you're yeah.
How do I put that cube in?
So there's that button above the decimal, the division, that up arrow. Press that. Look what happens to the box. It goes like up in the X bar, and then you can check it. Have a color. I'll give you the rulers here in a second. Let's go back. I'm gonna keep you connected. Drop it right here. Push this down. See? Reconnect you. And let's actually graph it. Now, the hard part about this, I think, is that when we plot these, we don't really know what these graphs look like. All right, lines, easy to draw, straight lines. Parabola is cool, just going to draw that E. But what does these actually look like? Well, let's at least plot some points and see where it is. So, first one down on the left. Pick whichever color you want for your first one. I'll go blue again. -5, -8. So that's right there. -4, -7. Go right there. -3, -6. Now, just for a second, pause after those first three. If you were to connect those, what is that probably going to look like? Looks pretty straight, right? If I connect those, it's going to be pretty straight. Tell you right now, it's not. Lines are straight. Everything else is perfect. And that's why this next point, -2, well, -2, 1, is not part of that straight. So I don't want to connect these yet until I get a good sense for what this is going to look like. And so if there is a way to actually, and I'm losing you guys just a second. If there is a way to actually see what this graph is going to look like, that would help us at least try to sketch it a little bit better. You guys know what do you think? What could be a good idea? Try to see what this thing looks like before we actually have to sketch it ourselves. That's all. Press graph. This is a graphing calculator. That's what it's good for. Press graph. Now the thing we got to be careful of, we want to make sure that what we're about to see is going to match kind of the space within it. And so you know how we press that table set to look to set everything up? Well, we press second window to do that. Window is what designs the screen to look the way we want. Now, x's go from -10, x min, first one, x max, y min, -10, y max, 10, perfect. Now, if you don't have that, there's an easy option. Okay, like I said, all these buttons at the top are all graphing buttons. And the one in the middle is to help you zoom. Now, yeah, you can like zoom in and zoom out. Actually, the standard viewing window, -10 to 10, -10 to 10. There's zoom trig, there's integers, there's stats. If you were actually doing some statistic stuff, we can zoom box. I'll show that to you one day. But zoom number 6 gives you that. There's those 3 points. 1, 2, 3, kind of all in a line. Well, at least it looked like a line, right? There was a point like right here, and right here that looks pretty linear, but it is not. In fact, you know, let me show you the zoom box right now. That's something. Zoom number 1, see that blinking cursor that I'm moving around? I'm going to pick a corner for what I want my window to look like. I'm going to pick a corner right there. Press enter, watch, change its shape. Zoom box. I'm going to scroll down and pull. What I'm making is the window. Now I press enter. That's what's really happening in that spot. That is not straight at all, right? But there's a point right here, a point right here, and a point right here that look like they could be in a straight line. Cubics are not straight. And so what we're going to have to do is we're going to have to freehand that curve as best you can. And it's not necessarily going to be perfect, and that's okay. But if you don't let the calculator help you graph, then what good is the graphing calculator? You know what I mean? So let's do it. Let's zoom back in. I'm going to repop this point. You haven't plotted it, right? But I have to erase it. Show you stuff. All right. So where were we at? -5, -8. Let me rehook up this. So, plot those 3, -5, -8. Like these 3 were all in a row, right? And then all of a sudden it jumps up to here. So what's going to happen in this space down at the bottom? We want to make it look. I'm going to draw it up here just so we have a visual. Like that's what that graph is. Okay, so it comes up pretty quick, but then those 3 points kind of represent this area right there. where that curve like flattens out and then heads back up. So when you graph this, this is kind of weird because it's happening down here, but like if I could, I would like come up real quick, hit that, and then I would flatten out and then head back up. Oh, I missed. Back it up. Can't cross that grid line until I'm supposed to. Now that's second at the bottom, we don't know that. That's kind of feeling of like coming up quick, flattening out, and then taking off. Now there's a point in -6, we just couldn't fit it, right? There's a point in -1, it just doesn't fit on the graph. These graphs keep going. We want to show that. So I want to extend it out on the bottom here. I just want to make sure I don't cross that next line because -6 was like negative, 12 or something. So I'm going to come down, but I just extend it out. Just don't cross that next grid line. Anything up here, I want to extend this up, but -1 comma whatever was just too big. So when I extend this up, I have to stay inside that grid line. Make sure I don't cross over this. You guys are weird. You haven't really messed around with them too much, but just have this kind of flattening out. Kind of plateaus for a second and then just takes back off. It's actually called flexing. Technically, that's the math term for that. Flex. Right, so on. Well, one thing this graph is missing though right now. Just the blue graph on its own. There, good. Keep going, right? The idea of extending this out is to show you it keeps going. All right, now we do the inverse. And that same kind of flexing is going to happen, so we just got to see where it happens. -8, -5. So I'm switching colors. I don't have red dots in both, so I'm sticking with the red. -7, -4, -6, I bet -3. So that's 3 in a row, right? And then 1 negative. The flexing happens like this. We'll let you know. Like this one is more like a J times, I don't even know what to call that. This one's more like this. Now I gotta get myself all the way to this point. I have to stay flat. Flat way. I gotta extend it, right? I'm gonna extend it out. I just can't go down to -6. I'm just gonna extend it, kind of stay in that box. I gotta extend this one out. I gotta get all the way over to there, and I can't go up to that next grid line. So I'm gonna stay pretty flat while I do it. But still kind of creeping up. And just like Dylan said, got this some arrows. All right, so there was our first function. Y. I showed this to us yesterday while you guys were online. So it's nice to label which one's which. Like find an arrow, put a Y next to it. Find an arrow, put a Y inverse. You switched it?
I don't understand color.
Oh, it's fine. So colors is optional. It just helps it pop, stand out a little bit. Especially when they cross. A lot of these are going to run into each other. And there's one other thing that we always want graphed in here. You guys remember what that was? What was that last thing?
The line of symmetry.
Yeah, perfect nice line of symmetry. Where is that? You remember where it is? Yeah, diagonal, right? But is it, which diagonal is it? Top right, bottom left, or top left, bottom left?
The one person.
I mean, look at that. There's no symmetry there, right? Always. Top right to bottom left. Here's where I think straight edges are just nicer to do it. You can always freehand it. Here's the thing. You heard me, I didn't say ruler. I said straight edge. Gavin, hold up your straight edge. What do I mean? Perfect. All right, that's straight edge. That works for me. Whatever you got, use tools, but obviously rulers always good. So that's the source for. I like that. Now, the thing about this line, it's not part of the graph. It's not the function, it's not the inverse. So we always dash or dot. It just kind of cuts right through all of these nice spots. And look, if they meet, it should go right through. Where the two pieces meet, the function and its inverse, doesn't matter in the end anymore, because that line does meet. That's the line. If you want to make sure it is actually symmetric, like turn your paper so that line is straight up and down. You should see that nice. That's the only weird one that we haven't really seen yet. Okay. Let's do it. Keep rolling. Let's do the algebra that happens behind the scenes. Of course, people at home, you can shout. Or go faster than me. Slow. All right, so table's done, graph's done. Now the algebra that goes with it. What is it? What? Oh, that one's dead. Oh, it's time. Oh, baby. Here we go. Vertex. Let's go. Hey, yes. 1 more, 4 for 5. 5 for 6. Russian. I was like, what, 3 for 30 last semester? And Fuego now. I was literally a 3 for 30. It was so gross. It was bad. I went on like an 0 for run, like unseen ever before. What is it? Parentheses x plus 4 minus 7. Hey, look, a vertex, -4, -7. Kind of, right? Like if this was quadratic, that would be the vertex. Before that turning point happens. Really, a vertex at the lowest point, but check it out. There it is. That's the point where it's flat. Cool. All right, let's find the inverse. What do we always do first? Listen, as long as it's y equals, which it is, it's not f of x or anything, we're good. It's literally, listen, y is x, x is y. So I call this step 0, right? If it's not y equals yes, then let's make it y equals. But if it already is, we're good. And it's just switch x one. Now, like I said, I'll only ever have just a single x and a single y. You don't have to worry about going all crazy. Let's solve for it. So we've got to find this. We got to solve for this. Kind of buried, stuck in there. Right side super complicated. Left side super simple. We got to switch that. We got to take all that stuff that's on the right and start moving it over to the left, so we can get y by itself. So what should we do first? Yeah, right? Any addition subtraction is always going to happen first. A little +7, a little +7. Right side just got a little bit simpler, right? Y plus 4 cubed, or to the 3rd power, either one. And I mean, we'll simplify as much as we can as we go, but usually what happens is the right side gets simpler as the left side gets more complicated. Stuff just moves that way. So, okay, like what are we going to write over here if it's x and then a +7? X plus 7. Like there's nothing to put together. They're just like one's an x, one's a number. Cool. I just write a message. Addition and subtraction done. Do you have any multiplication or division happening on that right side? Any numbers being multiplied through here? Any division happening? No, we're good. There's nothing over there. Like this, it's not like a 2 times whatever, or like a big fraction with a 5 on the bottom or something like that. There's nothing. The only thing I see is a little +4 on the inside and an empty. So I'm good. If I don't have anything, I can skip that level. Now I got to take care of that x. Yesterday we dealt with quadratics, right? It was like x squared, so we took the square root. This is not x squared, so square root is not enough. This is x cubed. Cube root is perfect. That's exactly right. That's what we're going to do. We're going to take the cube root, the little 3 up in that spot of both sides. Now, what happens in this level sometimes is that plus or minus, right? But that is only for even roots. When you take a root, it's got a number, right? Square root 2, cube root 3, 4th root, 5th root, 6th root. Only if that number is even. 3 is not an even number. So I don't need it. I can just let the cube root happen on the right, the cube and the cube root cancel each other out. And then it just happens on the left, the cube root of x plus 7. Right side got simpler, left side got more common. That's going to root up. Now we move up to the grouping symbol and we say, all right, cool. Now I can deal with what was inside. Add a little +4. Yeah.
What happened to the cube root over the y plus 4?
It canceled out with the cube.
Oh, okay.
Just like the +7 and the -7 disappear, we chose the +7 so that would happen. We chose the cube root very purposefully because it was being cubed to do the opposite, right? Addition, subtraction, opposites, multiplication, division, exponents, and roots are there to cancel each other out.
Oh,
Yeah.
How come you just dropped it down like the x plus 7 of the cube instead of-
This thing,
Yeah,
because it's just gross. Like, there's nothing nice about it.
yeah.
Just like I took x plus 7, right? I said, okay, I got x. I'm supposed to add 7 to the right. Let me add 7 to the left. But I can't put those together and make them simpler because like one was an x, one was a number. So I just wrote it, right? X was 7. Same thing from this step down to this step. I said, all right, if I've got a cube, I've got to undo that. We do the opposite. Okay, I'll cube root it. But this is just the cube root of x plus 7. There's just nothing I can do to make that simpler because it still has that. If there was a number there, then maybe I have a shot, right? Maybe I can take the cube root and get something nice. Just like, cube root of 4 is nice. Sorry, the square root of 4 is nice, but the square root of 5 is gross, right? Sometimes we keep it, sometimes we don't. This is still just x. So there's nothing I can do with it until maybe some kind of number goes. Good question. Nice. All right, so let's take care of that +4 with a little -4. A little -4. Finally, y by itself, good. And again, like nothing I can do here. I can't put the +7 and the -4 together. One's stuck under the cube root, one's on the outside. And so you can write it exactly in this order, right? Cube root of x plus 7, and then leave a little space, -4. You just want to make sure that that cube root stops right there. Or you can put the nice number up front, the -4 first. Sign sticks with it. Now, before it was like plus or minus, right? But I don't need a plus or minus because that's only for even roots. It's like, so if I don't put a negative in front of this cube root, can it be negative? If it's not negative, is it negative? No, of course not, right? So it has to be just the plus instead of the plus or minus. That little 3 at the next spot. Now, like I said, I am cool with this. If you want to just say, okay, cube root x plus 7, stop -4. Like make sure that root stops. You want to leave it like that? That's cool. So this is a nice separate version. We just usually like to put the nicer stuff up front and the not so nice stuff at the end. Got there. Now I have the y's on the right. Maybe you're okay with that, maybe not. For me, I'm not. I like to write it with the y on the left, everything else on the right. Just makes me feel a little better when I'm looking at it. Either way, something's still missing. Right, that last step, that's not just any y, right? That is a very specific equation that is the exact opposite of this one. So a little -1 right there, or right here. Come on. Right there, there, wherever you want to put it. I'm going to do it on. That's my favorite. That's probably the hardest one out of all of these in this whole thing. That cube root is a little different for us. And graphing it can be kind of tricky. The table is a little misleading. But the fresh graph, man, this thing gets a whole lot of it. Yeah, this is another cubic, but it's like number 7. So what do you think? How's that process sit with you? You feel like you got a pretty good handle on it? Then, you know what? Let's do this. Try number 4. On your own if you want. If you want to give it a shot, try it. Now, I'm going to do it, but I'm just not going to talk through the process as much, but I will give you some instructions on what to do. All right, so first, make an XY table. Okay, I will pull up my calculator to help you do that. Okay, number 2, make an X, Y, the inverse table. Okay. Then sketch those graphs. And include your line of symmetry. Okay. And then find Y inverse alpha. That's the plan here with number 4. Once you get number 4 done, you are done for the day. Okay. To try that out, I'm going to pull up my calculator's table back there in case you don't know. Yeah.
You want a website you can do
I downloaded calculator.
Did you try that?
Calculator X looks a little different, but I just downloaded calculator faithful.
That's the same.
Yeah, I just need to figure out how to do the same stuff.
Okay. So what's the app?
It's just calculator 84.
Calculator 84. Which makes sense because that calculator on my computer is a TI 84 plus color edition. The plus just adds a couple things, and then the CE color edition. But I will pull it up. But play with that and see if you like it. Because if that's good, then let's keep that. I'm gonna lose
right now, so we'll see.
Yeah, sweet. I like that. I would love. What's up, Jack? I would love for us to just be able to have that emulator on our phone instead of having to buy it. I just need like 5 minutes.
What's up, Jack? See you in jewelry, brother. I was not about to take the project again.
Wait, is it 2x squared minus 5? Is that what it is?
Yes.
Pulling it up. Yeah, apparently the app Calculator 84 seems to be the one that people are like. Alright, so I go to Y equals, I get rid of whatever's in there, and I said, I reset my table by going to TBL set, which is second window, changing my table start to -10. Now, big thing you want to remember, let me back up. The big thing about these tables, but the calculator itself, there's 2 buttons. There's a negative button and a subtraction button, and those are different. The first thing after the equal sign is a negative sign. The subtracting.
You leave it on auto?
Everything on auto, yeah, because if I go down and I change independent to ask, check out what happens when I do. Now, what it's waiting for me is to type something in. Hey, I want to know what's happening at -10. Then it automatically gives me the Y. So look, table set. Go ahead, ask me for any X values you want, and I will automatically give you the Y. That's kind of what's happening right there. So you could do that, and in calculus we do that because we mess with like numbers like that, right? Or like super small numbers like that, just to see what happens. That's a scientific equation. That just means -1 times 10 to the negative 10. Because you can only fit 5 digits in the table. Plus a decimal. Right, so we can only fit that one. I typed in 0.0000001. Right, there's my negative. All right, but to make our life easier, we just set it to auto. Let it automatically spit out the X's and the Y's for you. I can't get any of those. So we get negative 2. There we go. There's a nice little list. That's going. Oh, I did what? What do you mean?
I was just not doing it.
So you gotta go to Y equals, you gotta type in the equation. Yeah, see, the calculator is like that's why that button I think is top left. That's first. That is my first stop if I'm doing anything with graphing. I go to the top left and I type in whatever the equation is.
And then what do you do after that? Because I
Okay.
can graph it.
So graphing is nice because then you'll know what it's gonna look like once we actually graph it. But you want to set up the table first because that's what we have to do first. And so second window is table set. And you want to make sure that your table start is -10.
Yeah, I have that, but like I can't like see like,
That right there?
yeah.
So now look at the button graph, the graph button on the right. But look right above it, this table.
Yeah.
So second window is how to set up your table. Second graph is to actually see.
All right, I see it now.
Thank you. Yep. So just looks like -2 to what? Yeah.
Mine, I don't know what I did wrong, but when I put it in the graph, the y is in all negative. Okay.
I love this app. This is good. Okay, so now your table is set up. But now above graph, so second graph, there's your table that's giving you X's. Go back to table set. So second, go back up to that. Here we go. Okay, now try it. I don't know why it was. Yeah. Not quit. So, oh, you have to type it into Michael. You got to give the calculator the equation first.
What do you type in?
That 2x squared minus 5.
This is dry out.
That's good. You took care of addition subtraction first. It's like top left-ish. It says x, t, theta, and n.
That's a very
Oh.
Multiplication division would be next. You got that 2. You multiply through, divide it over. I'm gonna move the camera back here in a second. Let me just jot down.
Can you click enter on the other?
You should just be able to click table, like second graph should get you there. Like this. That's free too?
Yeah.
Yeah.
That is
You just have to
copyright
sign-
infringement. Okay, all right.
I just get.
Yeah.
Yeah, I just did my app like.
All right, cool. So there's that. Oh, let me get the.
Yeah, it's not too hard. That's fine.
That's all. No, 'cause we can all have some kind of graphics out there on our phones or physically. That's gonna make a huge difference. And I'm talking huge difference. Like this is quick. Like we'll be done with this like in a week or so. We get to chapter 4 and I start using other stuff. You can't do it without a graphing calculator. You literally can't do it. So that's gonna save us a ton of time. That's awesome. So there's my XY. Now this is just quadratic, so it should look nice. It should be pretty set up. Look good. I'm gonna graph from next. We've got like 5 minutes, so if you don't have to go rush. But once you get number 4 done, I'm good. We'll do 5 and 6 tomorrow. At least I might even jump to the cubic one again tomorrow. I might do like 5 and 7 tomorrow, and then leave 6 and 8 for you guys on Friday. Yeah. So same thing like we did on Monday. Yes, right. Oh, you have it though? You have the copy? Okay. So, you want to just show them to me right now? All right, cool. Take them out here. Sit in this number 1 right here, Jack. Finish up one quick thing. And then I'll take a look. I'm going to do the algebra first, actually, since it's up here. That. That's for tomorrow.
And so, modified block plot. I need help mapping the block plot or do I not do that?
Yeah, it's tricky when they don't give us it all scaled out like that. That's okay. Good. So that's 6A, B, and 7, right? Good. Okay, let me see. So, 6A, 6B, 6C, and 7. Good. Okay. That's way back in the day, right? Yeah. Okay. Good.
Wow. Any other way? Wow. Ugly.
This is what I gave you the.
Don't fool yourself, Nick.
Oh. So that goes back. So that's what, 2, right? That started with number 2.
Yeah, let's into
Okay. B and C. Yeah. Okay. Nice. And then none of the stuff from this unit has gone in yet. So all of the standard deviation stuff, put that on canvas for me.
Okay, cool.
I'm gonna grab this one, make sure it looks good. I'm gonna bring the camera over. Yeah. As long as you're gonna bring one on Monday. What do you think?
Hey, Rosie.
Yeah. You didn't need it. Oh yeah, what's up? Who's talking to me at home?
Oh, okay. I didn't know if you were talking to me. Sorry. I have 2 questions. One, so I didn't submit submit anything through the test under the modules. I didn't submit anything through there, but I did them. Do I need to how do I need to submit anything through Canvas for that?
You did the in-class test in class.
Yeah.
You did at-home stuff at home. The
Yeah.
Canvas was only there for somebody that was taking the at-home test, or the in-class test at home.
Okay.
So you are good. If you did the Google form at home, and you did the in-class test here, then you're good.
Okay. Sweet.
I haven't put the grades in yet because not everybody has taken the in-class test yet. That's what I'm waiting for.
Okay.
So, but I got everything from you guys, and you're good.
All right. Sweet. And then my other question was, do you put the recordings of this anywhere? Because I had a hard time following along today, so it would be easier if I could go.
Yeah. So what happens is, if you go to our class,
Okay.
and then you go to pages,
All right.
and then at the top there's a button that says view all pages.
Oh, I see it. Gmeet recording links.
There they are. Yeah.
All right. Sweet.
After the end of 7, I gotta do 7 period.
Okay. Sweet. Thank you.
And there's your ground code from the timing. You got 10 seconds. So again, nothing to submit until you get everything done. Okay? Until all 8 of these questions are done, nothing to submit. I will see you guys